Let's collect the heights of 15 fellow students in our statistics class, and we obtain the following data. So we have a data set, which I call H for heights. Everything is measured in centimeters, and there should be 15 data points there. So these represent the heights of our 15 fellow statistics students. The first part of this question wants us to build a frequency distribution of this data with a lower class limit of 150. So we're going to have a lower limit of 150.0 and an upper limit of 174.49. Oh, 174.9. All right, so that's my lower limit, and my upper limit, that's the range of the distribution that I want to build. And I want to separate my data into 5 equally spaced classes. 1, 2, 3, 4, and 5. So the next class would have picked up at 175.0. Ooh, that was bad. 175.0. So my data range, I can think of that as approximately 25, right? Technically, it's 24.9, but the next class would have picked up at 175. So this range here is about 25. And if I want to separate a distance of 25 into 5 equally spaced classes, then each class should have a space of 5 units, right? This is 25 centimeters of space. I want to divide into that 5 classes. So each class will have 5 centimeters. So my class width here is going to be 5 centimeters, meaning that my first class is going to go from 150.0 to 154.9, because my next class picks up at 155.0. Right, remember, class width is defined as lower limit minus lower limit. All right, my second class is going to end at 159.9. My third class is going to pick up at 160.0. It will end at 164.9. My fourth class will begin at 165.0. My fourth class is going to end at 169.9. And my fifth class is going to pick up at 170.0. And then it will finish taking me to 174.9. So this is a good way to visualize what's going on. Typically, when we write down frequency distributions, we'll use T-charts. So we'll have our classes here and the frequencies of those classes here. So the first class is going to range from 150.0 to 154.9. The second class begins at 155.0 and goes to 159.9, and will continue in this manner. All right, now we just have to go through our data set and count how many are in each class. So this would be a good point if you wanted to reorder the data set H. You can do that by hand, but because we have 15 values here, it'd be a good idea to put this into Excel and use their tools so that you can go to data and then go to sort, and you can sort it by value. But long story short, if we fast forward through that process, we see that we have 4 different values inside the first class. We will have 2 values inside the second class. We have 5 values inside the third class. The fourth class contains 3 values, and the last class only contains 1 value. So if we did our job right, the sum of the frequencies should be equal to the total number of data points that we have. So I should get 15 here. If I add 4 and 2, I get 6. And then I add the 5, I get 11. I add the 3, I get 14. And then I add that 1, I get 15. So all of my data is accounted for. So this is a frequency distribution for our data. The second part of the first question wants us to visualize this frequency distribution with a histogram. So we have class 1, class 2, class 3, class 4, and class 5. On our y-axis will be our frequencies. Class 1 has 4 data values in it. So 1, 2, 3, 4. Class 2 only contains 2 data values. Class 3 contains 5 data values. Class 4 contains 3 data values. And class 5 only contains 1. Right, so this is a nice way to visualize our data. We can easily see that class 3 contains most students. Most students are somewhere between 160 and 164.9 centimeters. All right, so that's the frequency distribution. And now we can turn our attention to number 2. We want to build a cumulative frequency distribution from the data. So cumulative frequency distribution, it cascades. We just collect more data as we move through the data range. So again, we'll open up a chart. We'll have our classes and our frequencies. So cumulative frequency distribution will be any value less than 154.9. Actually, we'll do less than or equal to 154.9 because that's the upper limit of the first class. So if you were 154.9, you would still be in that first class. So how about instead we say strictly less than 155.0. The next class will be strictly less than 160.0. The next class will be strictly less than 165.0. The next class will be strictly less than 170.0. And our fifth class will be strictly less than 175.0. All right, so the frequencies. How many students have a height strictly less than 155.0? Well, that would be the 4 that are inside the first class. How many students have a height strictly less than 160? That would be this 4 that's inside the first class, but then also these 2 that's inside the second class for a total of 6, right? As we go down, we just collect more data points. For our third class, how many students have a height less than 165? You could be in the first class or the second class or the third class for a total of 11 people. Students having a height strictly less than 170 gives us 14. And finally, how many students have a height strictly less than 175? Well, that was everybody. So 15 students. And we can again visualize this cumulative frequency distribution with a histogram. So we have here, we're going to have to scale our y-axis a little bit differently. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. All right, so for class number 1 in our cumulative frequency distribution, we have 4 students. For class 2, how many students have a height less than 160? We had a total of 6 students. Class 3, students having height less than 165, we had 11. Right, we jump up quite significantly because we had a lot of students inside class 3 in our original frequency distribution. Class 4 in the cumulative frequency distribution are those students that have a height less than 170. So we have 14 of those, right? Really everybody except for that last person. And then once we get to our last class, this has to be everybody. So we have all 15 students there. All right, right? It's a cumulative frequency distribution. You accumulate the heights as you go. Finally, we want to build a relative frequency distribution from the data. So again, we'll have our classes. And here our classes will be as our original distribution was. So the first class will be between 150 and 154.9. The next class will be 155.0 to 159.9, 160.0, 164.9, 165.0 to 169.9, and 170.0 to 174.9. For a relative frequency distribution, it's exactly what it sounds like. We want to find out how the size of each data class relative to how many data points that we have. So in the first class, we had 4 people. So relatively, it's 4 out of the 15 total. So this is relative frequency. In fact, let me amend our second class. This is cumulative frequency. For our second data class, we added 2 people. So this is 2 out of the 15. There were 5 people in the third data class. So there's relatively 5 out of 15 people. There were 3 people in the fourth data class. So there are 3 out of 15 there. And there's 1 person in that last data class. So only 1 out of the 15 have a height in between 170 and 174. And again, we can build a histogram to represent this frequency distribution. So if we have our relative frequencies here and our classes, then we're going to end up with the exact same shape as our original distribution. We're gonna end up with a shape that looks like this. Really, instead of comparing each data class to the size of our data set, which is 15 students, we're really comparing it to 1, right? We rewrote these as fractions. So now we've got 4 out of the 15. Here we have half of that. We have 2 out of the 15. Here we have 5 out of the 15. Our fourth data class had 3 people out of the 15. And our last data class, the smallest one, only had 1 person out of the 15. So notice that if you add up all of this area, you've got 4/15 there, 2/15 there, 5/15 there. And if you added up each one of these, you should get 1. Right? And this is going to come back when we talk about probability distributions in a huge way.